Good morning. This is Tuesday, Jan 21st, lecture 1, CS797K, binary hex modulo parity, logs and powers. In this lecture, we're going to dig into the basic concepts of binary hex modulo parity, logs and powers. It's a simple lecture. You're going to, it's, yeah, we assume you already know that, know all this stuff. Yeah, so this is just a quick refresh. Let's go. Questions to ponder. How high can you count on your fingers? This is supposed to be an interactive class, but the weather didn't support us. So you can unmute it, or you can keep in class chat. How high can you count on your fingers? Not your legs, but your hands. Just your hands. You can unmute. This is supposed to be interactive. Yeah, type in your chat. I can count 10 because I have 10 fingers. If you have 11 fingers or 12 fingers, you can count to 10, 11 or 12. I have 10 fingers. I can count to 10.
Here's someone typing. And exclamation. Let's see, how much is 10 factorial?
Teams 10. Exclamation. Okay. Let's see. I can count to 1, 10, 24. Yeah, we'll come. Yeah. We'll see it later. Yeah. Number basis 1, 10, 12, 20. What's that? Decimal base 10. Base 10 decimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 to 9, 0 added later here. Geodecimal base 12. We use it in clocks, zodiac signs, solar calendars, eggs, dozen eggs. Yes. 3 joints per finger, point thumb at each joint in turn. Yeah, I'll just show it on camera. Where's camera? I will open that. That's okay. Yeah. Let me zoom in. Camera controls. Oops. Mm-hmm. So I can count. Well, I think I need to. Mic. It's cold in here. I can count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I can even count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 25, 26, 27, 28. Yeah, with this finger, we can count. Yeah. So this is me, Ajay. I'm gonna teach you this semester for Tuesday, Thursday, and there is Professor Alden sitting right there. He's gonna he's hiding. He's gonna teach you Monday and Wednesday. And this is empty. No one showed up. So yeah.
Okay, back to the slides.
Yeah, back to slides. Yeah, that's the counting.
There's more.
Yep.
More coming.
More counting. Yeah, that comes later.
Okay, here we go.
Yeah.
So,
Yep. So base 10, base 12, we use it in zodiac signs. 0 to 9, X and Y. Backwards 2 and 3 if PowerPoint. Elf 11, 12 indicate early base 12 in Germanic language. This French So professor willing to keep all these as jokes.
Yeah, well, again, French,
French
in
with
case 20.
yeah. So number two, binary. So computers are, you know, computers need to keep something in binary, like 0 and 1 digits, 1 digit per finger, 1025 max on your fingers, right? This is 1, 2, 4, 8, 16, 32, 64, 128,
56,
56, and
512.
512.
Yeah.
So you can count up to 10,
So 22.
1024, yeah. So this is 1, this is 2, this is 3, uh, like 1 plus 2 plus 4 gonna be 6, and so on. You can count it like 1025 max on your 10 fingers. So yep, how maximum you could count on your fingers, it's 1024. So whereas in decimal each place is 10 times the previous, you know that. In binary each place is 12 twice the previous. Number bases 3, yes. We have octal and hexadecimal. Octal is base 7, counts from 0 to 7. Each octal digit maps to 3 binary digits because 7's gonna be 111, right? So 3 binary digits. So base 8. So each octal digit maps to 3 binary digits. Useful on ancient computers with 36 bits. Hexadecimal base 16, 0 to 9 and A to F. So 10 is A, 11B, 12C, 13D, 14E, and 15 is F. Uses 0x prefix to specific hex. Each hexadecimal digit gonna map to 4 binary digits. So base 8 gonna be 3, base 16 gonna be 4, 1111 gonna be 15. And useful on modern computers with 64-bit words. 2 hex decimals is 1 8-bit byte. Octal and hexadecimal are shorthand for binary. Yeah. So this hexadecimal base 2, base 10, base 16, you could see. You can see like 0 0 0 0. In base 10 it's gonna be 0. So this is 1, this is 2, this is 4, and this is 8. So this is 0, this is 1, and this is in second place. So this is 1 and 2, we add it up, you get 3. So this is 4. So add 1 plus 4, that's going to be 5. This is 1 plus 5, that's going to be 6. Sorry, 2 plus 4, that's going to be 6. Is 1 plus 2 plus 4, that's going to be 7. So this is how we're going to calculate base 2 to base 10 and base 16 as well. So binary you have till 0 to 9. I mean, not binary, it's decimal.
0 to 1.
Yeah. And base 16 we're gonna have till F, that's 15, 0 to 15. So we know this already. This is just to give you a glimpse. Uh, Now hexadecimal on your fingers, as we already discussed. There's 1, that's 2, that's 4, that's 8. So 1, 2, 4, 8. So you show up your fingers, you just add it. 1, I mean, if you're gonna show your in this finger and this finger, and you close these two fingers, it's gonna be 4 plus 1. That's be 5. That should be 5. So that's how it works. And here, Padmasambhava, he knows binary. You see the hand. So what's he showing? 1 plus 8. That's gonna be 9 in total. 1 plus 9 and 1 plus 8 is gonna be 9. So Padmasambhava, he is a Buddhist. So he introduced tantric mantras to Buddhism. If you need some ancient history, it's interesting. 1 plus 8, it's going to be 9. So he's from Tibet. Yeah, perfect. Warning about finger. So middle finger is considered quite rude in some places. So make sure, depending on which finger you choose one, be very cautious to show 4 or possibly 2 if you count the other way. So be careful with showing your fingers for binary. Cautious. Yeah. So check your comprehension. What is 7 in binary? You can, yeah, you can chat or just unmute yourself and say something. Yeah. Yeah, Vinayak.
Vinaya wins.
111, yeah, he's the first to answer.
So,
And someone is,
answer it, we'll go to the next question.
yeah, someone is typing. Yeah, that's okay. Yeah, the answer gonna be 111. Yep. What's C in decimal? Hexadecimal C in decimal.
This is hard.
This is not hard.
It's not hard if you know.
Yeah.
People don't know about hexadecimal. We'll see the first person gets the right answer. There we go.
Yeah. Mixed answers. It's 12. A is 10, B is 11, C is 12. D is gonna be 13, E 14, and F is gonna be 15. And in binary, what's hexadecimal 3C in binary? That should be easy, but yeah. So heads up, hexadecimal gonna be represented in 4 binary digits. So don't trust professor. So he's gonna lead you to wrong answer. So it's 00111100. Is it?
Exactly what I typed.
But that should be in 4 bits.
Yeah. And first.
Vimalan. Yep. Yeah, you could do that. Yeah. But that should be in 4 bytes. So just like you need to do separately for 3 and separate for C. So hexadecimal in A, in decimal or binary. Simple. And we express with 4 bits padded to make clear the relationships. Yes. 0xa in decimal and binary. It's simple.
Yep.
It comes after 9. Okay, that's gonna be 10 in decimal, 1010 in binary. Yep, perfect. And 1101 in hexadecimal and decimal. Yeah.
So, wait for an answer.
So 1 plus 4 plus 8.
13.
Yeah, perfect. 13's in hexadecimal gonna be. Yep, that's it. Now, modulus and mod m is gonna be r remainder. So let's. So there's. Yeah, this is gonna not work out the game to play because we are not in class.
Describe the game.
Yeah, that's a game called Beach Buzz. So we'll just count the numbers 1, 2, 3, 4, 5. Like we'll take turns to count. So first person gonna say 1, next 2, next 3, 4, 5, and so on. So if we say mod 3, so if the number is exactly divisible by 3, then we'll say bis. So 1, 2, bis, 4, 5, bis, 6. Oh, sorry, that's 7, 8, and bis. So like that, we'll take turns. So the person who gets the mod 3 as 0 should say bis instead of 3. So, and again, if the number comes 7 divisible by perfect divisible by 7, then we say buzz. So 6 gonna be biz, 7 gonna be buzz, 8 biz, and 14 is gonna be buzz. What if both say biz buzz? So we can add as complex as we want. We can play if someone's in class, but
chat.
Chat?
Let's try in chat. Let's try counting.
yeah, this will be fun. This will be fun. The class will be fun if we're gonna attend in class.
One, two. Is okay, Ajay, you're great. Type something up there.
4.
Okay, someone online. 5. Okay, who's next?
Yep. No.
Nope.
Nope. Nope. Biz. Yeah.
Yeah. Okay.
Next thing.
Is
No, not 7. Not 7.
7.
Buzz. Yes. Perfect. 8. Yeah. I'm gonna type. Biz.
Type it. Biz, that's right.
It's not Biz Buzz.
Not Biz Buzz yet. What is Buzz Buzz?
Biz Buzz gonna be the number that's gonna divide by 3 and 7.
So we'll keep going. So we did
Yeah.
at 9, no Biz, or 10, 11. Yep. And then after 11 comes
Biz. Yeah.
Biz,
Perfect.
and then 13.
Mm-hmm.
Okay, and then after 13,
Yeah.
and then 15 is Biz. 16.
16.
I'm getting there with 16. Yay. 17.
Yep. 18. Yeah.
Slacked in at 19.
It's more fun on chat.
19. It's kind of fun on chat.
Yeah.
It's just a mess, isn't it?
Yeah.
We'll see who's 21st. 20.
Biz Buzz. Yeah. Perfect. Yeah. So, yep. That's how we play this game. Just to get an idea of mod.
Yeah.
We can add the complexity. Biz, buzz, box, anything. Bay. And backward, we can count from 100 to 1, 199, 98, 97. We could play. We could add all the complexity. Yeah. And then Boolean and bitwise. It's freezing. It's high. It won't work, I guess, right?
Yeah, I don't know. Yeah. It's going to warm up here a little bit. I think what's happening,
Uh-huh.
the
And yep, Boolean, bitwise operations. Boolean's gonna be and or not. Bitwise gonna be and or not. Yep. Ampersand. Yeah. Increment, decrement. 5 and 3, true, right?
True.
3.
5 and 3 is 3.
3.
AKA true.
5 ampersand 3 bitwise. That's gonna be 0, 0, 0, 1. That's 1.
Right.
Yeah. So what does ampersand do? So if one of the bit is true, it's gonna give us, I mean, both the bits are true, it's gonna give us true. If either one is false, it's gonna be false. The vice versa for R. For R, if one of the bit is true, then the output will be true. And for XOR, it should be both the bits to be false or true to make the output true. We know that. We know the and or and XOR operations. Parity. We have even and odd parities. So n mod 2 0 for even parity, n mod 2 1 for odd parity. N is nothing but number of ones. Okay? So counts the number of ones bit in the binary representation of an object. Parity is another word for modulus 2, n mod 2. Yes. So there are many ways to count parity. So this is one of the way to count in Python. We're just defining the parity x, and we can call the parity in our program later. So yep, that's a parity, just even or odd parity. Have any questions on parity? It's simple. You'll get more clarity going on into the lectures. It's simple. Count the number of ones. If you need even parity, if the number of ones are even, add 0. If the number of ones are odd, add 1 to make it even. And the same for odd. If the number of ones are odd, then add 0 for odd parity. If the number of ones are even, just add 1 to make it even parity in the front of the bits. We'll see that later. So this is the example. 14.
Going into details on.
Yeah.
Basically, on the left, that's Python code.
Yep, that's the Python code. Yeah.
Install Python and run that code. And you can
Yeah. If you install and run the code, yeah, it works.
Watch it, calculate it.
Mm-hmm. Check your comprehension. What is 7 in binary? Again, chat. Yeah, someone's typing. Yeah, 0 1 1 1. Yes, perfect. What is this parity? I mean, parity, even parity. What is, make it even.
Parity of 7.
What is parity of 7? Even.
So what is?
Yep. So this how we gonna do 1. The parity is 1 because 3 ones are odd. To make it even, we're adding 1. So to make it even, so it's 1. The answer is gonna be 1.
Yes.
Yeah. Yeah. They yeah. Yeah. What is parity of hexadecimal 3C? That's a tough one. Take your time. It's not tough, but 3 in binary gonna be 0 0 1 1. C in binary gonna be 1 1 0 0. So what's the parity for that? Um, no, the answer should be 0 because it's even. Count the number of ones. If the number of ones are even, then it's 0. If the number of ones are odd, then it's 1. Yeah. So 7. Count the number of ones. 1 plus 1 plus 1 is 3. 3 ones. So it's odd. So we are adding 1 to make it 4 ones. So if we see, yeah.
Number is odd parity.
Yeah, this number is odd parity. Yeah. And then like ones, just count the number of ones 4. So this is even parity. If it's odd parity. If the number of ones are even, it's even parity. 4 ones here, so it's even parity. 3 ones here, it's odd parity. That's it. It's simple. Count the number of ones and tell us that if it's even or odd. Okay. So now, what's the parity of 14? 14 1 1 1 0 binary representation. Number of ones, count the number of ones, and if the number of ones are even, it's even parity. If the number of ones are odd, it's odd parity. It's 1110.
We'll wait for someone else to type it.
I,
So I'm gonna type in binaries 110.
so it's odd.
Right.
Perfect. That's it. Even and odd parity. Yeah. One, that's odd parity. Yeah, it's simple. I think, is it clear? Or if someone has any questions on parity, just unmute or type in chat. Yeah. Yep, that's all it.
Let's ask another question before we go on.
What's the parity for?
I want to ask if they can name the kid.
Yeah.
Name an odd number
With even parity.
even period. Okay, we'll see if any what kind of answers we get here.
Yeah.
Okay. Someone's going to take it.
Yep.
Who's going for it? It's 101.
1 plus 2 plus 4 plus 1, 5. Odd number and even parity.
Yep. Well, I don't know. Because that's specified. It's 5. 5 is correct.
Yeah.
Yeah. If we go to 101 in decimal, and we take that in binary, and 101 is correct. Both answers.
Yep. It's not 101, it's 5.
101 in
Both.
binary is
You need to answer in
6.
decimals, not binary. Yep. Yep. Perfect. 3. Yeah. 3 is even parity and odd number in decimal. Yeah. Let's
Okay. Thank you.
let's dig deep. I mean, let's go on. Let's move on.
Okay.
It's the next gonna be logarithms and exponents. The power 10 square gonna be 100 in Python. The exponent power is star asterisk 10 power 2. So 3 is 100. So that's how we're gonna use it in Python. We're going to discuss Python in one of the coming lectures. So in logarithms, log 100 base 10 is gonna be 2. It's simple. 100 is gonna be 10 square. Takes 2 to the front. 2 log 10 base 10. Log 10 base 10 gonna be 1. 2 times 1 is gonna be 1. 2 times 1 gonna be 2. So in Python, you need to do like math.log x. So math.log 100 comma 10 100 base gonna be 10. So that comes the answer 2. Natural logarithms e 2.7182818 so on. This log 4 e power 1.38629 3.99998. Simple math. So mod plus logarithms equals integers. Yeah. So in near lectures, we're going to discuss about finite fields. So integers are infinite, finite fields. So integers are infinite, real numbers are even bigger infinite. Integers are like fractions, 2.3, 3.4, integers 2 by 3, something like that. So yeah, so real numbers gonna be even bigger infinite. So integer mod value are finite, correct? So this means logarithm in finite fields are integers. Yeah, though, so
It's confusing now, but we'll see that.
yeah, you may be confused with this slide, but yeah, you will get clarity if we dig deeper into our mathematics lectures, math lectures. Yep, so that's all it for today. So that's gonna be the end of the lectures, and Professor Wilner is eager to show you a magic trick. So let's see how it goes.
Let's see how we can do this.
Yeah.
Let's try this.
Let's switch on the camera. That will work.
Now, turn that off, I think.
Or you
go
could
here.
show here.
We gotta go here. Camera controls. This is how.
This camera control.
Camera. Exit page.
No.
PC right is going to be the lectern camera.
Oh, okay, that works.
Okay, now go back to screen sharing. See
Yes.
what they're seeing on screen.
Yeah. Hey.
Okay, now you need to take the camera out of the way.
To you?
On the second screen there. You got your camera. No.
No, I'm just saying. Yeah.
We switch this back here.
Yeah.
Put this back. PC right. PC right currently has this. We get that out of the way. We're sharing the screen. We put this up to lectern camera and there. Now, go out on the screen here and verify that you can see this. Put your hand up, sir. Not working.
It's not working?
Go back to here and make sure you're sharing the screen.
No. Yeah, just a minute. Huh?
Where's the meeting go?
It's here. Come on. Should I reload? Oh. Happen something?
Yeah, try it.
Yeah. Teams. I'm gonna share my screen again. I mean, can you hear me now? Yeah, okay, thanks. Now let me yeah, I got it, chat. Yeah, I'm visible to them. So entire screen share. Oh no, they're just giving thumbs up for me.
Oh, just a thumb up.
Yeah.
Got it. Okay, so now
I'm sharing.
sharing your screen.
Yeah.
Screen that you're sharing is screen, window, or tab. Choose what you want to share. Screen, this one. And the problem is that I'm not actually.
Okay.
What am I missing here? Okay, we're going to do this. Go back to the camera, start the camera back up again. We'll go back here. You're sharing your screen. You're up there, right?
Yeah.
Okay, now they can see that. So go ahead and Zoom in on,
Zoom right
on
here
the screen up there.
on the screen.
Yeah, go up to the screen.
Okay.
We'll do that whole self-engulfing thing.
Camera controls.
Yeah, and then over a little bit. Oops,
Oops.
way over. Now we change this so that, and this is lectern camera on the screen.
On the screen, yeah.
And now we can see what we're sharing on the lecture. Now put your hand in the way.
You can see that?
Yes. All right. Let me hand the microphone back and forth.
Microphone?
Yeah. All right. This, I'm not sure how well this is going to work, but we're going to try to do a parity trick. This is usually done with cards. Each card has 1 on one side and a 0 on the other. We lay these out. Unfortunately, the cards are very large, so we're not going to be able to do that on the space we have available. So we're going to use these little dots. There went a dot. Lost a dot. Some of these have a dot, or these have dots on one side and not on the other. And hopefully we won't have too many cards where we lose things. So you get to be the magician.
I?
Yeah, tell me to
Okay.
put up, yeah. Tell me to put these cards down and I'll leave it out. You're going to ask me to do.
No. These are sticking.
Yeah. They're going to be sticky to each other.
And it's smelly.
And they do smell really bad. It is amazing how badly these things smell. All right. Okay, so I've put out 9 cards in the little square here. And now you're going to be the magician? Or am I going to be the magician?
I'll be the magician.
Okay, so Ajay is going to make things harder by putting out more cards,
Oh.
right? And your cards are going to be I want to start this one, I think, over here so it all fits. Okay, so go ahead and make your 4x4.
4x4. Yeah. This one? No?
No, this one.
Wait.
Keep going. All right, so now we've got a grid.
Mm-hmm.
And so, well, do me the trick. You're going to turn around.
Uh-huh.
Okay. You gotta do that in line so people can hear you.
Okay. I turned around. I'm not seeing the cards now.
So I'm going to flip over one of the cards. We're not
Yep.
going to tell them what it is. Close your eyes because you can see this on the screen. Okay. All right.
Okay. So I haven't seen what card was flipped. So that's going to be this one and this one. Right?
Right.
Yep.
Yes. That was much less impressive than if we had a student doing it.
Yeah. So the whole point is, so one card's gonna be flipped, and
So we're going to do this the fun way here.
yeah.
Close your eyes.
Okay.
Don't look in the chat.
Okay.
Here we go.
I'm not looking the chat.
He's not allowed to. Well, I just.
You're done?
Yeah, don't look at it.
Okay, okay, okay.
Okay, here you go. So, Ajay is now going to figure out which of those is flipped over. Go for it.
Okay.
Drum roll, please.
This is the one.
Right there.
Yep.
Yep.
Correct.
Yep.
Yeah.
Column 2, row 3.
Yeah, column 2, row 3. Yep.
Yeah. Column 3.
So yeah, this is a fun magic trick we thought to show you, but no one's in class, so this is gonna be fun if someone's gonna in class. Yeah, we'll also do it next week. So
Explain the point. How it works.
how it works? Yeah.
Or should
So
we leave it for later?
yeah, yeah, we'll leave it for next week. Yeah. So we'll figure out what's the magic trick for next week. So let me attendance. Before that, do we have anything?
Do we have anything else?
No, one homework.
Homework. Oh, yes,
Yeah.
homework. Discuss the homework. Okay. Now we need to put this back to.
Oh, it's camera. Okay, cool. Camera controls. Zoom out. No?
Yeah. Now you can exit page and take us back to PC right.
Okay.
And
Okay.
go
Got
back
it.
here and go back to. Oh wait. Um,
Okay. Got it.
something. Man, I did not know this was so smelly.
So we have a small fun homework this week. Okay. So I'm just going to make it available for you guys, visible to students. So this is the small homework to ASCII hex. If you open the homework, there's a document file with the instructions. So what you're supposed to do, oh, oops. So ASCII, so you know the ASCII table, American Standard Code for Information Interchange, was first published in 1961. So it described 7-bit binary. So what you need to do, just find a ASCII table and use it to encode your name. Okay. And then subtract it with hexadecimal number 10 from every character and look up for the ASCII character of those hexadecimal codes, post the resulting string. You'll get some meaningless word, so just post that. Extra credit? No, it's not extra credit. No. So is the parity of your gibberish string even or odd? Just if it's an even parity or odd parity, check that and let us know. So again, it's not for correct or wrong answers. You just need to upload some document to get your mark for the small homework. No one's gonna ask you for the correct answers, but yeah, try to find an ASCII table, encode your name with the ASCII values, and subtract hexadecimal 10 from the ASCII values, and again encode it back into the ASCII alphabet. And the due date, uh, Jan 21st. Yeah, we'll change the due date.
Yeah, you can do that
Right now. Mm. So when's the due date?
It should be Tuesday.
28th.
Yeah.
So the due date is 28th on that. It's simple and it's a little fun. You just spend like 2 or 3 minutes on that, and it will be done. Sorry. Yep. Now the other homework. So small homework 1, it's integrity contract. Just sign the integrity contract, and just your signature, your name, and your WSU ID and the date. So just use the digital signature, or you can just put your signature on that. Anything is fine as long as you submit it correctly. Integrity contract is important, so just don't forget to submit it before the due date. And it's an easy point to get, 1 point for integrity contract and 1 point for ASCII hex. Okay. So that's all it. And we have attendance today. So we're gonna do a quiz today. Let me copy. Oops. So open the attendance Jan 21, 22, 2025. So we'll just start it now and we'll be finishing it up in like 8 or 9 minutes. We have more questions for ADS. So I'll just post the code on chat. So this is the code. Just go ahead and finish up your quiz and you're good with the attendance for today. So yep. If you have any questions, concerns, just let me know in the chat box or you can just unmute yourself. So let's wait for 7 to 8 minutes to finish up quizzes for everyone. So, have you finished with your quizzes? Anyone still doing that? Because I'm gonna close the quiz now.
Someone is not finished.
No one's not finished. It's
Someone's
completed.
finished. Okay.
Yeah.
Anyone else not finished?
Hmm. It's
Anyone
12:24.
not finished? That was what we're looking for. Anyone who's not finished.
Mhm.
Clock.
Your quiz is mandatory for attendance.
Yeah, although since it's first week, can't say the goal.
Yeah.
This is practice.
Clock is ticking. Yep. So we encourage people to come in class. So that will be fun for ADS because we have a lot of stuff to do in class. Yeah. Yeah. So yeah, you can attend anytime, like Monday, Wednesday, Tuesday, Thursday. That doesn't matter. But try to show up in class
So again,
next week. Yep. Anyone not finished? Yeah, everyone's finished. So attendance. I'm going to stop it now. Yeah, done. Yep. I think.
yes, we're going to do that tomorrow. For ADS and PDS, we're going to do the quiz. Reminder, no class Thursday.
Oh, I need to stop recording.